you have 10 minutes in your presentation, so I will give you a 2-minute warning before the end. Okay. Start now? Okay.
Good afternoon, professors. We are from Carmel Holy Resident Study School. Gregory Tan, and this is my teammate Barney. Today, our research paper is a study on polyhedron with all triangular faces, co-spherical light-cone circles. And today we are going to present the conditions for the existence of the 6N-point sphere. And we will skip some of the definition, some of the proof and analysis in our paper due to the limit of time. First, we would like to remark some definitions and properties of the tetrahedron. We define the 3D additive and the 3D normal as shown in the figure. And we call if the force of perpendicular from the vertex of two adjacent faces are coincide, we call the two faces having a coincide force. And if orthocentric tetrahedron having coincide fit on every edge, which means the orthocentric tetrahedron exists is 3D orthocentric. And in an orthocentric tetrahedron, the 3D additive pass through the orthocenter as well. And if you use vector to represent a tetrahedron, orthocentric tetrahedron, here has this property. And that's our theorems. In the only if part, for any triangular polyhedron, there are 3 points lying at the edge, which is the midpoint and the 2 feet from the 2 adjacent faces. And if this 1324-point sphere exists, since a line only intersects with a sphere at no more than 2 points, so 2 of those 3 points must be coincide. If the feet and the midpoint coincide, one of the edge will become the tangent of one of the light-cone circle. So we can see they are not co-spherical. Therefore, the 2 feet must be coincide, and the tetrahedron must be an orthocentric tetrahedron. Furthermore, it's important to notice that if the 6N-point sphere exists, the polyhedron must have the coincide foot, and this is an important lemma in your research paper. And in the if part, we have found 2 proofs for this part. The first one is about the co-spherical point. We can see the sphere alpha beta and the sphere beta gamma also pass through the 4 common points. And since a sphere only can be formed by 4 non-coplanar points in 3D space, below they are the same sphere, so the 24-zone sphere exists. The second proof is about the normal of the on the center of the light-cone circles. Due to the limit of time, the detail of the proof please refer to the part 2 of our research paper. And we have theorem 3. The 36-point sphere doesn't exist. If the 36-point sphere exists, any 2 adjacent spaces on his hexahedron OX, Y, Z, P must have coincide foot. To consider the tetrahedron OX, Y, Z, that must be an orthocentric tetrahedron. And we noticed that an orthocentric tetrahedron contains 2 equal circles in this 24-point sphere. So the center of the 24-point sphere must exist inside the tetrahedron. So the 14-6-point sphere cannot have 2 centers. Therefore, the 36-point sphere doesn't exist in hexahedron. And then we have theorem 5 and 4, and this 36-point sphere doesn't exist. The 36-point sphere exists if and only if the octahedron DABCDF fulfills the following conditions. First is the 3 angles of a tetrahedron are perpendicular to each other, and the 2 is OA product OC equal to OB product OD equal to OE product OF, where O is the intersection of AC, BD, and EF. First, we assume that the 48-point sphere exists, and any 2 adjacent spaces have coincide foot. To consider the projections of EB, FB on AB, we have the first equation. And to consider the projections of EB, FB, and on BC, we have the second second equations. And we can see they are coplanar. The ABCD are coplanar by the similarity. Next, to check whether they are perpendicular, we know A dot B equal to A dot D since they have the coincide foot on A, and C dot B equal to C dot D because they have coincide on C. And we can see they are also perpendicular to each other. Next, using the midpoint on the sides of quadrilateral, we can form 3 rectangles, and using the concentric properties, we can easily to prove the second conditions. And we noticed that the 12 midpoints lie on the edge of a cupola. That means we can see a pair of the cupola, a pair of the opposite circle of a cupola is equal. So we can see the intersection of the diagonals of a cupola is actually the center of the 46 point here. In the if part, we try to introduce the 3D coordinate system, and the coordinates of 12 midpoint can easily be found in the that kind. And we can find a point G, which is mentioned previously. That's equidistant with that distance. So therefore, we know the point G is equidistant from all the midpoints. Therefore, the 40x points will exist. A more serious proof to provide is consider the shortest distance from the original point. We know the 2 adjacent faces must have coincide foot. So the basis condition of the 13x points will exist. And before we start our study on polyhedron, since it's not easy to define the height of a polyhedron, we try to define the 3D attitude to be the normal of the center for the polyhedron. And we have theorem 10. If 3D oval center HC and 3D circumcenter OC exist, the center of the line-axis endpoints will exist as well. Consider the midpoint between the 3D oval center and the 3D circumcenter. We know the midpoint, and consider the euler line. The line point circles must be the midpoint of the oval center and the circle center in the face. And we can see the midpoint of the 3D oval center and the 3D circumcenter is actually the projections of the midpoint. Therefore, the normal of the line point circles are concurrent, so the 6 endpoints will exist. And we have theorem 11. If the 3D oval center exists in a triangular polyhedron, then the triangular polyhedron can be divided into n ovocentric tetrahedron. By considering the tetrahedron formed by the 3D oval center and a triangular face, since the height of the tetrahedron is the normal of the oval center of the face, the tetrahedron is an ovocentric tetrahedron. And hence, we can imagine the triangular polyhedron can be divided into n ovocentric tetrahedron. And that's the end of our theorems. And in this presentation, we have proved the 5 theorems. And here is some theorems then present. So that's all our presentation. Thank you.